Hey everyone, I'm here to teach you pH calculations. It's Mrs. Buchholz here, sitting at home. The first thing I want to talk to you guys about a little bit is the fact that pH is a way for us to tell if a chemical is an acid or a base. And we can tell just by the number if something's an acid or a base. So generally speaking, pH of 7 is neutral. pH below than 7, so less than 7, is considered an acid. And pH of greater than 7 is considered a base. And you may already know that, but I just wanted to quickly remind you that that's the pH scale, and that's what we use to tell if something is an acid or a base. Now what we're here to do today is to learn how to calculate pH. And the hardest part about this, honestly, is just plugging the numbers into your calculator. I'm going to start by giving you some formulas we're going to need. Now, the first formula is the formula for calculating pH. So if you can write this down, please, it's pH equals the negative log, and then we're going to use these brackets again. And I'm going to remind you that those brackets mean concentration of H. We're going to be using this formula today, as well as this one. There's also something called POH, and that equals the negative log of the concentration of OH minus ions. And then finally, there's a relationship for these two. When I add pH and POH together, I get 14. And finally, this is our KW formula from last week. It's 1.0 times 10 to the negative 14th equals the concentration of H plus times the concentration of OH minus. Now, a couple reminders about things that I think would be helpful for you. The first of which is what the names of these are. So just a reminder, first of all, that H plus is also known as H3O plus, and the name is hydronium. A lot of times they try and fool you on the homework, and instead of using the symbol, they use the name. And OH minus, just a reminder, is hydroxide. Now, if you've never seen the log symbol before, don't be too concerned by it. It's just a button you're going to push in your calculator in order for us to do calculations. So let's go ahead and get started and do our very first calculation. So we're going to start off, I'm going to go ahead and write an example over here. We're going to find the pH if the concentration of H plus, again those brackets means concentration, is 2.5 times 10 to the negative 9th m, and just a reminder, m is molarity. Okay, so the way we're going to attempt this problem, we know H, so let's look for what formula has H in it that can help us find pH. It's this formula right here. So I always start by writing down that formula. pH equals the negative log of the concentration of H. And then we're simply going to use substitution just like we have before. We know that this is our concentration of H, so we're going to plug that value in here and then solve the problem. So if I write down pH equals the negative log, and now I substitute this number in of 2.5 times 10 to the negative 9th. So let's plug that number in here. And again, I'm just going to replace it with E. Okay, so now let's talk about how we actually plug this into our calculator. This is what needs to get plugged in. All a log does is it makes this negative 9 not seem so important. It makes very large and very small numbers seem kind of more like what we call normal numbers. So let's talk about plugging this in. On a different screen, I actually have a calculator that looks a lot like some of the ones that you guys have. So I'm going to go ahead and type this in there. So I'm going to take the negative log of 2.5 e to the negative 9th. Let's see if this works. Okay, so here is the calculator. By the way, where I pulled this up is on actually the MCA practice test for Minnesota. So if you were able to find that and pull it up, that might be helpful for you. It looks like I need to clear my calculator. And the way you type it in, I'm going to go ahead and hit the minus button, negative, and then I find the log. Now be really careful. If you're using your phone calculator, it's what's called log base 10. It might have a little 10 by it. And then I'm going to punch in my number, 2.5, and we've used this E button before. I'm going to do second EE, negative 9, and then my enter. And my pH is right here. It is 8.60. Now you're probably wondering about sig figs. Generally speaking, we give pHs to 2 decimal places, but it's nothing you're going to be tested on. But generally speaking, that's how we give it. All right, let's do another one. This time, instead of finding pH, I'm going to say to find pOH. So find pOH if the concentration of OH is 1.7 times 10 to the negative 10th m. All right, so again, we're going to look at what's given. I am given the concentration of OH. So I look over here at my formulas. The one that has the concentration of OH is right here. I'm going to write down that formula and then substitute in. So pOH equals the negative log of the concentration of OH. And again, I'm going to substitute that value in. So pOH equals the negative log of 1.7 times 10 to the negative 10th. And then let's go ahead and use that calculator again. So this is what I'm going to plug in, the negative log of 1.7 times 10 to the negative 10th. So I go back to my calculator. I'm going to clear it out. And again, I hit negative log of 1.7 and then times 10 to the negative 10th. And again, I got this calculator on the Practice MCA site. 9.77 is what that rounds to. So again, we tend to go to 2 decimal places. So equals 9.77. So that is a really brief introduction on how to calculate pH and pOH. But I'm going to do one more, and I'm going to make it a little tricky and involve this formula. Okay, so the last question I'm going to do is going to be find the pH if the concentration of OH is 2.45 times 10 to the negative 4th m. So let's talk about what's different about this problem, okay? They're giving me the concentration of OH, which if I look over on the left-hand side, means that I can use this formula. But the problem is they're not asking for pOH, they're asking for pH. I call this a two-step problem. See, here's what I can do. Since I'm given the concentration of OH, I can first find pOH. And I can use the pOH equation since I'm given OH. So watch what I do. pOH equals the negative log of concentration of OH, and then I substitute in that value, the negative log of 2.45 e to the negative 4th. So let's go ahead and type that into that calculator, 2.45 e to the negative 4th. So again, negative log of 2.45 e to the negative 4th. And I get for an answer 3.61. So I go back. My answer for pOH is 3.61, okay? But they don't want pOH, they want pH. So my second step is to use this handy formula right here. It's kind of a fun, tricky formula. Do you see how if you take pH plus pOH, you get 14? Well, that means I don't know pH, but I do know pOH, and that total equals 14. Do you see that I can just take 14 minus the 3.61, and that's going to give me my pH. So let's go back to my calculator. 14 minus 3.61, and I get for an answer 10.39 is my pH. All right, so if you guys are looking at what problems you can do now in your packet, take a look at part 2. I'm going to tell you the one thing they'll kind of throw at you sometimes if you take a look is that sometimes in these problems, instead of writing it like these problems are written, like this, they will instead of using the symbol, they're going to say the name. And so don't be thrown by that. You need to just remember whenever they say hydronium, they're talking about H+. Whenever they say hydroxide, they're talking about OH-. So if you wanted to go ahead and try and get started on part 2 of the packet, you can do that now. I'm going to take a quick peek here and we're going to see what part of the packet you all can work on at this point. But for now, go through the ones where it's asking you to find pH or pOH. All right, thanks for listening.